We want to talk about the ARDL. What is ARDL? ARDL stands for Autoregressive Distributed Lag. Autoregressive distributed lag models are used in econometrics for analyzing the relationship between variables. Over time, it is typically used when researchers are interested in examining both short-term and long-term relationships between variables in a dynamic system. ARDL models combine autoregressive and distributed lag models to account for both short-term dynamics and long-term equilibrium relationship in a statistical model. This approach allows for a more comprehensive analysis of the impact of various factors on the variables of interest. Researchers often use ARDL models when they suspect that the variables under consideration are interrelated and influence each other over time. So by using ARDL, researchers can analyze the dynamic interaction between variables, determine the direction and magnitude of their effects, and make more informed conclusions about the relationships being studied. Overall, ARDL is a powerful tool in econometrics for analyzing time series data, and can also provide valuable insights into the relationship between variables in a dynamic system. Now let us look at the data set we are going to use for this ARDL example now. Yeah, so this is the data set. Now, in this data set, we have the various headings. We use Excel. The VSP uses Excel as its own default data set file. Now, in this, we have the columns A to K, and column A is firm. That is the name of the firms that will be used. You can see them lined up: Maxi, Lakes, Flax, and so on and so forth, and many others just like that. Then the second column here is period. The period here refers to the time period that each of these data can take. And then, of course, you have the third column, which is a group. And then you have the variables. You have egg, sal, ink 3, ink 2, ink 1, oil, SES, and meal. Meal here is taken as the dependent variable, while the other ones are the independent variable. Now let's go and see how we do this analysis. Okay, so now let's so now let's do it. Okay, now so we can now concentrate on this. Let's see. So to do this, we go to the research data menu, and we click it open. We go to the ARDL co-integration analysis. I'll click it open. Now we wait for the the form. Yeah, the form now opened. Now all we need to do is to do what we need to do here, and that is we have to the dependent variable here is meal. The independent variables are ing1, ing2, ing3, egg, SAL, SES, oil. You can see as usual that I didn't have to put any space in between. I only separated this variable just by the use of comma. Now time, because time and groups are not needed here, so they have been disabled here, so nothing goes in here. Then all we need to do now is to go to the name of the dataset file, and the name of the dataset file that we use is some task. Now, of course, it's an Excel file, so we don't need to put the .xlsx. We don't need it, so we simply just click this, and to go to process what we have. Yeah, I think by now it should have finished processing. Now let's see. It has finished processing. Now let's see what it did. So this is the ARDL, the Autoregressive Distributed Lag co-integration. Yeah, you can see the engine values here displayed, the trace statistics. You can see the critical values also displayed, and then the OLS regression, and with all that is there to be displayed. The AIC, that is Archaic Information Criterion, is this, and then the Bayesian Information Criterion is also this, and then the covariance is non-robust. And of course, you see the R squared and the adjusted R squared. Now we come to this place. It uses the T, that's the parameter estimate, uses the T, and the p-value is suggesting that except for the constant, none of other ones are significant at the 5% level. You can see the confidence interval at upper and lower, and then the W-Watson statistics, the Jackie-Bera statistics, the probability of the Jackie-Bera statistics, and the additional. You can see the kurtosis, and of course you see the probability of the omnibus. That's the omnibus is 3.02, and the probability of that. Then you now see that it has standard errors. Assume that the covariance matrix of the errors is correctly specified, the conditional number is large at 5 point, that's what it's trying to show us here as the conditional number here. It's large at 5.1. It's a scientific notation. This might indicate that there are strong multicollinearity or other numerical problems. So, and it's also trying to tell us that the analysis results are in C, value starts, autoregressive distributed lag, reg.txt result. So that is about the ARDL.